By the end of this video, you will be able to calculate an average rate by drawing a secant between two times and finding its slope with correct units. You'll also be able to calculate an instantaneous rate at a chosen time by drawing a tangent at that point and finding its slope. Lastly, you'll be able to calculate the initial rate by drawing a tangent at time 0, the steepest part of the graph, and finding its slope. Rate of reaction means change in the measured quantity per unit time. Typical units, depending on what you measure, are grams per second and grams per minute when it's mass versus time, moles per second when you convert mass to moles, and centimeters cubed per second when it's gas volume versus time. In this experiment, we'll mainly use grams per second. This is our graph of mass of carbon dioxide produced versus time for the reaction between calcium carbonate and hydrochloric acid. The slope of this curve at any point gives the rate. If you'd like to see more about the reaction between calcium carbonate and hydrochloric acid, including how to do this experiment, then check out this video. I'll leave a link in the description below. Let's start by calculating the average rate using a secant. Here's a question that would prompt you to do this kind of calculation. Using the graph of mass of carbon dioxide produced versus time for the reaction of calcium carbonate with hydrochloric acid, calculate the average rate of reaction between 0 seconds and 260 seconds. Show your secant, triangle, working, and units. A secant is a straight line that joins 2 points on the curve. How would you draw it? Well, you'd choose the 2 times specified in the question, place the ruler so it passes through both points exactly, draw the line long enough to read the grid cleanly, then make a big triangle to measure rise over run. Here we have to use 0 seconds and 260 seconds. The mass goes from 0 grams to 0.55 grams. So the average rate is the change in mass divided by the change in time. So 0.55 grams divided by 260 seconds gives you a rate of 2.12 times 10 to the power of minus 3 grams per second. If you wanted to convert this to moles per second, you would divide by 44 grams per mole, which is the molar mass of carbon dioxide. Now let's move on to calculating an instantaneous rate using a tangent. Here is an example of a question that would prompt you to do this. Using the same graph, determine the instantaneous rate of reaction at time equals 180 seconds by drawing a tangent and calculating its slope. Show your construction, working, and units. A tangent touches the curve at one point and shows the slope at that instant. How would you draw this? Put the ruler so it touches the curve at your chosen time, adjust until the edge matches the local direction of the curve, and extend it across the graph. A long tangent reduces error. Choose 2 well-spaced grid points on the tangent for the calculation. The tangent I've chosen to draw 180 seconds crosses the grid at 40 seconds, 0.3 grams, and 260 seconds, 0.6 grams. So the instantaneous rate is 0.6 grams, take away 0.3 grams, divided by 260 seconds, take away 40 seconds. So 0.3 grams divided by 220 seconds gives you a rate of reaction of 1.36 times 10 to the power of minus 3 grams per second. Lastly, let's calculate the initial rate using a tangent at time equals 0. Here is an example of a question that would prompt you to do this. Using the same graph, determine the initial rate of reaction by drawing a tangent at time equals 0 and calculating its slope. Show your construction, working, and units. The initial rate is the slope right at the start. How would you draw this? At time equals 0, set the ruler so it follows the steepest, earliest part of the curve, then extend the line and use 2 far apart grid points. Using 0 to 160 seconds, the line rises from 0 grams to 0.52 grams. So the initial rate is 0.52 grams divided by 160 seconds, which equals 3.25 times 10 to the power of minus 3 grams per second. To summarize, the average rate is the slope of a secant between 2 times. The instantaneous rate is the slope of a long tangent at the chosen time. and the initial rate is the slope of the tangent at time equals 0. Always draw long lines, pick widely spaced points, and include units.